Hey techies, so hopefully this one isn't going to be as long as the last video, but this month's training is going to be on the Petrogen torch. So Petrogen torch on the rescue, it's going to be located in Officer Compartment 1, up middle shelf. The objectives: you need to understand how to use the Petrogen torch, what a Petrogen torch is, know the difference between other torches. You need to have the ability to assemble our torch for operation, have the ability to begin using the torch, understand the process of how it actually works, effectively be able to cut with the torch, terminate the torch operation, have the ability to disassemble it, and recognize the safety concerns and measures taken from the torch operation. So first thing, everyone needs to find, locate, and read the torch manual. It's located in the Target Solutions Training, or you can just go to Petrogen, their website, and download it. Inside there, breaks it up into a few different areas. You get system components, the system assembly, light up procedures, storage, cutting basics, advanced techniques, maintenance, troubleshooting, and repairs. So for our Petrogen torch, our system components, we have the liquid fuel torch, so that's going to be the part that you're going to hold. The liquid fuel hose, that's the red hose that connects to the liquid fuel tank. You have the oxygen hose, that's the green one, that hooks up to the oxygen regulator and then into the oxygen bottle. We break that down a little bit more. Onto the liquid fuel torch, you have the tip, self-explanatory, the tip nut, that's just the nut that goes around it. Torch head, that's actually the 90-degree bend in the torch. You have a preheat oxygen knob, just look at the green arrow. You have a high pressure oxygen trigger. You have a fuel control knob, that's the one between the two hoses. You have the oxygen hose connector, which is just the nut for the oxygen hose. You have the oxygen flashback arrestor. That's the magazine looking thing between the oxygen hose connector and the actual oxygen hose. What that prevents is any sparks, embers, anything like that traveling back through the fuel torch and ultimately lighting the oxygen tubing on fire, which would be bad. You would go boom. The liquid fuel hose connector, again, that's just the nut for the liquid fuel hose. The liquid fuel hose is the red arrow. Again, that's the red hose. And then, of course, the oxygen hose or the green hose. So then we move over to the fuel tank. So on the fuel tank, you got a hand pump. You'll find that that's going to be your best friend. The fuel tank pressure gauge, shutoff valve, filter cap, the liquid fuel hose, and there's a 2-gallon top weld line. If you guys look at the white arrow, there's a weld line, or if you guys actually go out to the rescue and look at the liquid fuel tank, you'll see a welded line just before the top crest of the fuel tank, and that's your 2-gallon fill line. Next, go over to the oxygen regulator and the bottle, the oxygen bottle. We have two of them on the rescue. The smaller one, primarily used for training purposes, and the larger one is going to be reserved for incident only. If you look at the actual bottle pressure, or the oxygen regulator, excuse me, the dial on the right-hand side is the bottle pressure gauge, so that tells you how much oxygen you have in the bottle based on pressure. Then you have the output pressure gauge, which is the dial on the left, and that is regulated by the regulator control valve. You have the oxygen bottle valve, which is just the screw valve on top of the bottle. and you have the oxygen hose. If for some reason you're looking at the oxygen tank and you don't see the oxygen bottle valve, just unscrew the cap, because they're all capped to keep the oxygen bottle valve protected. So just unscrew the cap and you'll find it right there. So the Petrogen torch, what it is, it's a oxygen fuel torch. The fuel that it uses can either be gas, it can be diesel, it can be kerosene or any other type of fuel. The only one that we're going to put in there is unleaded gasoline. There's other attachments and things that they sell for the other types of fuels, but the only one that we'll be using is gasoline. So there's a few different other torches roaming around. Adams County, they've got a plasma cutting torch, and then you've probably heard of oxyacetylene torches. The main difference between like a plasma torch, so a plasma torch uses electricity. It changes the electricity to create plasma, and then it uses excuse me, it uses compressed air to shoot the plasma, the superheated plasma, through the material, and that's how it cuts. For a oxygen fuel torch, it heats up the metal because the flame is so hot, and that will continuously keep on cutting until you stop applying the fuel mixture to your cut surface. So there's some pros and cons. A plasma torch, you have to have an electrical supply. A oxy fuel torch, like the one we have, it's a little bit more portable. So if you're going quite a ways out, or you're in an area where there's no electricity, you can't, throw a shoreline over to it, this is definitely the torch that you're going to want to use. Another thing is that a oxy-fuel torch, like the Petrogen that we have, can only cut ferrous metals. So it can't cut aluminum, it won't do cast iron, it won't do stainless steel. It's got to have, the metal has to have some type of iron in it. So any of the structural steels, anything like that, that's mainly what we're going to be using it for. The plasma cutting torch can cut ferrous and non-ferrous metals, so there is a positive for that. One of the biggest positives that you'll find using a oxy-fuel torch is the depth of the cut. With the appropriate tip size, as you guys will see later on, we can actually cut up to 14 inches of steel. That's pretty crazy if you think about it. So, setup. You pull out the drawer in Officer 1 and you see the bottles laying down, you got the hose cart, you got the hose rolls, and the oxygen tank. First thing you want to do, you want to take the cart out, set the cart down on the ground, and load up one of the bottles, whichever one you're going to use, the training or the instant bottle. Make sure that you chain that up. From there, take your liquid fuel tank, place the liquid fuel tank in the basket, and then take all of your hoses and put your hoses with your cart. That way it's all in one tight container. You can wheel it wherever you need to. On the rescue, there's also a orange toolbox. In that toolbox, you'll find all of the spare parts, all of the cleaning tools. You'll find the sparker, a wrench. There's probably a couple pairs of gloves, safety glasses, all of that in that orange toolbox. So it's definitely a good idea to grab that orange toolbox. Either take those parts out, put them in the cart, or just carry the box with you. So here is the cart all set up, ready to operate. If you look, what you will have to do is you'll have to connect the oxygen regulator to the oxygen bottle. That's that picture up in the top right corner. There is a set of channel locks currently to use that with. We will be getting a open-ended crescent wrench, or excuse me, just an open-ended wrench that is sized specifically to that regulator nut. That way we don't run the risk of stripping the nut in the future. And then down below, you see just how everything is set up. Now on the fuel tank, this is important to note because you're going to have to set your pressures for your oxygen tank, and you're going to have to set your pressure for your liquid fuel tank. So if you take a look at the liquid fuel tank, when you guys get out there, there's a table. What the table is, it's a tip selection chart. So this is kind of what it looks like. This is the tip selection chart out of the manual. The one on the liquid fuel tank has the exact same information. Has all of the tip numbers over on the left hand side, followed by inches. Those inches are how thick of metal you can cut. So if you look all the way down, tip number 8, we can actually cut 12 to 14 inches of metal. And then after that, you have your fuel and your oxygen. Those numbers represent the amount of PSI that is needed in each container to effectively make your cuts. So our tip that we have on currently is a 83, so it'll cut between 2 to 4 inches of steel. We need to increase the PSI on the liquid fuel tank between 10 and 20 pounds, and we need to regulate the oxygen bottle between 35 and 40 pounds. Well, it's pretty simple to do. You can just turn the regulator until the outlet, that's the gauge on the left, reads between 35 and 40. Now getting the liquid fuel tank up to pressure is a little bit more cumbersome. So there's the hand pump on it, and what you're going to do is you're actually going to pump the liquid fuel tank until your dial reads between 10 and 20 pounds. If you only go to 10 because you get tired, just know that over time, as you're using the fuel, it's going to dip below that 10 psi that's required, and you're not going to get a valuable cut. So if you can pump it up to 20, that's going to be your best bet. That's going to give your most fuel time. So that right there just goes to show you, just keep going that over and over and over and over. It's probably going to take between 100 and 120 pumps in order to get it up to pressure. So now that we're able to assemble it, let's see how we go to start it up. So first thing you want to do, now that you got all your pressure set, go ahead and take the fuel torch. Take the torch, hold it in your hand. Alright, now remember the knob between the two hoses is your liquid fuel knob. What you're going to do is you're going to want to turn that half of a turn.
Half turn?
That's it, just a half turn. The system, and all we're doing there is depressing that high pressure oxygen trigger for 3 seconds. It doesn't take a whole lot to purge the system. Then after that, you're going to turn your oxygen control valve 1/2 turn. That's it. So half turn, purge, and then another half turn. That is it. Oh, sorry guys, we're going to go back real quick. I want to show you. So if you take a look at this picture down on the bottom right hand corner, you see the valve that the liquid fuel hose is connected to. If you guys actually look at the liquid fuel tank, you'll be able to see it a lot better. But what this is this is the check ball valve. This is stored in the closed position. and it needs to be open in order to operate it. So what this does is this regulates the flow of fuel between the liquid fuel tank and the liquid fuel hose. So if you get it out, put it in the basket, and you just open it up all the way, it's not going to work because that check ball valve will just automatically activate and it will shut off your system because it thinks that there's a sudden change in pressure. So what you need to do, you need to pump up your liquid fuel tank up to that 20 or 10 to 20 psi, and then just do a quarter turn. That's all it takes, is a quarter turn of the check ball valve, and let the fuel pressurize that liquid fuel hose. Let it sit there for 30-45 seconds, open it up another quarter turn, wait another 10-15 seconds, another quarter turn, then another half turn, and then by this point in time you should be able to slowly and progressively just open it up all the way. If at any time you're doing this and it's quiet enough where you actually just open it up all the way and you hear a small little click, that means that check ball valve is activated, and what you need to do, you need to shut down that valve and start the procedure over again. So let's get back to where we were. Alright, so now we're prepped, ready to go. We're ready to light this bad boy. When we do it, you want to make sure that you test the starter prior to attempting to light. What we're doing here is we're making sure that there's flint actually in the starter. If not, grab one of the extra flint packs out of that orange toolbox. And in addition to that, you're also checking to make sure that there's enough steel on there, because it's just a simple flint and steel system that causes the spark in the starter. When you go to put the starter up to the fuel tip or the torch tip, don't put the bellow of the starter directly in the fuel. If you do that, you're just going to saturate the flint and the steel, and you're going to create too rich of an environment for even a spark to generate. And then obviously it's going to be too rich for the gasoline to actually light. So pay attention. I'm going to show you this quick video on starting it. When we're doing it, take notice as to what the torch tip sounds and what it looks like, because a lot of what the next couple things are based off of is just sound and visual, what it visually looks like. So if you guys saw, there was a lot of yellow and it sounded really rough and really abrasive. That's perfectly fine on a cold tip. That's to be expected. We'll show you now how to fix that. Pre-cut prep, or it's just warming cutting tip. So what you're going to do, you're going to take that cold tip. Don't press the high flow oxygen or high pressure oxygen. Just take your torch, take it to your cutting surface, and actually physically place the tip on the cutting surface at a 45-degree angle. It only needs to be on there for 3 to 5 seconds to warm up the tip, but what it does is when it does warm up the tip, you'll be able to notice the difference between the flame pattern and the sound. So all that's doing is warming up the tip. So if you see there, we got a lot more blue in our flame. It's more of the, I call it a highway sound to the flame. And we didn't change or modify the oxygen or the fuel knobs at all. So again, take a look at the difference between the two. So here's the cold. Here's the hot. That was the hot. And here's the cold. So even just based on the picture right there, you can see the difference in the two. And we didn't change the settings at all. That's just what the tip when it's warmed up. The reason that happens is because the warm tip will actually start to evaporate the gas as it gets to it, and it disperses the gas. When the molecules heat up, they get excited and they get a lot bigger. So that expansion of those gas molecules actually allows for a hotter burn than just what the cold tip does. So from there, let's go ahead and test out some cuts. Almost. So when we're getting ready to cut, identify the material that you're going to cut. If you got a chalk or a lumber crayon, anything like that, pencil is sometimes hard to see, but if you can mark the actual cut, it's going to give the person doing the cut a guideline of where to go, and just kind of it helps out the process a whole lot. So if you can make a mark on your material, that's great. Go to your leading edge of your material. So like on this piece of steel that we're cutting, it's going to be the edge, and hold just the flame. Probably it's about a quarter of an inch, a quarter to 3/8 of an inch away from the material. What this is going to do, it's going to heat it up, and then once you see the material start to get molten, that's when you depress that high pressure oxygen trigger. Once you do that, start to move your oxygen tip along that cut line that you identified, keeping the cutting tip at a 90-degree angle to the material. Some people, the manual says 90-degree angle. Some of the classes I've taken, they'll say make it a little bit sharper of an angle. So what you're actually doing is forcing that flame into the oncoming material. Because the way that the Petrogen torch works is that as it's cutting, the molten material that is in front of the flame edge is actually heating up the next material getting ready to be cut. So that's just a constant process. Most importantly, make sure that you keep a smooth motion going through this whole thing, and that you keep your high pressure oxygen trigger depressed at all times. All right. So this is what it looks like. So that's just a straightforward cut, going from the leading edge of the material in towards the center. If you're doing thicker material, if you read the manual, they'll talk about a Z cut, and what that is, or a zigzag cut. That's just a really small zigzag pattern up and down as you're moving in that lateral motion, just to get more surface area to heat up the material in front, so it makes the cutting a little bit easier. So another type of cut that we can do, it's called, what I call is punching. All you're doing is really creating a hole in whatever material that you're going to be doing. So this is really helpful if we have to get like a search camera through a piece of steel, or we need to use a piece of steel for an anchor point and we can't go around it. We can actually go through it. That's some pipe dream stuff, but this is how you do it. So you preheat the steel just the same as you would a straight linear cut, except for starting at the edge, you start at the middle of where you want the hole to be. So you identify your hole, Start preheating the middle. As soon as that gets molten, then you depress your high flow oxygen trigger, and then you move in a circular pattern from the inside of it to the outside, and then you get your desired diameter of your punch. Pretty simple. It's pretty fun. So some troubleshooting things. Flame direction. You always want your flame direction and all of your sparks and everything to be shooting out the bottom of whatever you're cutting. If it's shooting out to the side, let's say you're cutting a thicker piece of metal and starts shooting out to the side, that's a key indicator that you're not making a cut that's deep enough. You're not penetrating all of the material. So something to do at that point in time, make sure your tip size is right, make sure that your mixture isn't too lean or too rich, make sure that you're depressing the oxygen trigger. Also, if all of that's right, something you guys might be able to go to is that zigzag cut, just to increase the heat that's being distributed. So pay attention to your flame direction. So this is what it should look like. So see how the sparks and everything are just going out the bottom.
So what happens is there's a break in here. That just separates from the metal. So it wasn't eating the second piece. So right here, go a little bit slower, and maybe the tip a little bit closer.
So what happened there, we were having Russ cut that piece of steel, and on the outside is a cog gear, and then it's actually welded to a disc in the center. So it's two separate pieces of steel. He was able to cut the cog disc, but the heat wasn't transferring over onto the steel disc on the inside. So I told him, slow down a little bit, take your torch head and put it a little bit closer to the material, that way it heats it up a little bit better, and just make that transfer a little bit smoother. And he did it a second time. Unfortunately, I don't have a video of it, but he did it a second time and it worked great. Worked just fine. Some other things you could run into are slag. What that is that's the all of that extra, the molten metal that looks like it turns hard, but it's still hot as hell. Looks like it turns hard, and it will actually connect your pieces back together. Try to avoid going back and hitting it, because you could get like a slag explosion or a slag burst, and it could just pop up. If it pops up, it pops up. It shoots embers everywhere. It's cool. It's scary, but it's just unfortunate. Try not to do it. It doesn't make for a pretty cut. Pour cuts. Yeah, if you're getting slag or you're getting a lot of pour cuts, you're probably going too slow on your cut. So speed it up a little bit. Try to push all of that molten material back out the bottom, and as soon as that's pushed out, keep on moving on. So if you're standing in one spot too long, it's going to push it all out in the kerf cut. The kerf is the space that's actually being cut. It's going to push out the kerf, and then it's going to start to melt everything around it. That's what happens when you go too slow. Incomplete cuts, again, that's just you're not heating up the metal all of the way, or you got the wrong tip size, your mixture's too lean or too rich or anything like that. Ultimately, pay attention to the troubleshooting section in the operations manual. So now it's time to shut it down. We're done making our cuts. Time to pack it up for the day. So first thing you want to do is you want to shut off your liquid fuel control knob. That's the one between the two hoses at the bottom of the torch. So shut that one down completely. Then shut down your oxygen valve, and then just purge the tip. So just lightly press the high pressure oxygen trigger for a couple seconds just to push the rest of the fuel out of the torch. Now, you may ask, well, what if I don't shut it down in that order? What's going to happen? Well, this is going to happen. So, that's what you want to avoid. You just turned it into a flamethrower, more or less. And you run the risk of that flame going up, lighting the rest of that liquid fuel on fire if you do that. So don't do it. So after you shut down the torch, it's hot, right? No, it's not. Nice thing about a Petrogen torch is that with the speed that the high flow oxygen is coming out, and also with the evaporation of the liquid fuel, it actually cools the tip. So you could take a bare hand right now and touch that tip, and it would be nice and cool. That, say if it's a really hot sunny day, then the tip might be heat up a little bit, but it doesn't get heated up from the actual flame. So now you go over to your liquid fuel tank, and you still have 15 pounds of pressure in there because you didn't use below the 10 or anything like that. That's fine. We just want to store it unpressurized. So if you take the cap that's in the middle of the liquid fuel tank that says Petrogen on it, just start to unscrew that. Don't unscrew it all the way, otherwise that cap will go shooting. But unscrew it, start to relieve that pressure. So you guys can hear that pressure being bled off. So just keep unscrewing it until all of that pressure goes away. And yeah, after you do that, what we want to do for storage and for packing it up, what we want to do is we want to take all of the liquid fuel out of the hose and put that back into the tank. Waste not, save not, right? So just unscrew the liquid fuel hose connection from the liquid fuel tank. Totally unscrew that Petrogen cap on the liquid fuel tank. Take the hose and stick it in the liquid fuel tank, and just use gravity. Start at the end with the torch. Totally take your hoses and lay them out nice and flat, nice and straight, and start on one end and walk it like we used to with the hose. You're just draining all of that fuel back into the end. While you're doing it, a good idea is to actually to open up the liquid fuel valve that's on the torch. Otherwise, you'll create a vacuum in the system, and the fuel won't totally empty out of the hose. So after you do that, pack it up the way that you saw it. The oxygen tanks go on the left-hand side of the pull-out drawer. The hose gets coiled in the middle. The liquid fuel tank finds a nice happy home there in the back right corner. But the most important thing to make sure it fits is the way you put the cart in. Put the cart in with the tongue or the base facing up and facing out, all right, because that actually butts up against the shelf right above it. If you load it the other way, it's not going to fit. If you load it upside down, it's not going to fit. This is the only way that it will fit in that compartment. So before you guys get out there and you start cutting, some things that you need to pay attention to are going to be the PPE. Just make sure that you're wearing, just get out there, put on your BDUs, all right? 100% cotton. We want to be in flame retardant material. Do not wear your bunker gear while you're doing this, because if you get some hot slag or something like that on your bunker gear, it can actually start to damage them. We would much rather replace a $30 pair of BDUs than a $700 pair of bunker pants. Same time, make sure you wear a pair of natural gloves. So when I say natural gloves, I mean either structure gloves or like leather gloves. Just know that leather gloves, you don't have any thermal protection, so you can actually start to feel the heat through the metal. Do not wear rope gloves. Don't wear any gloves with polyester in them, anything that will melt if it comes into contact with the heat. Make sure you're wearing safety glasses. On top of wearing safety glasses, make sure you're wearing actual ANSI approved eyewear. All right, the torch burns hot, burns bright. On a nice bright day, it's not going to affect you as much as what a dark day would affect you with your eyesight. But make sure you're wearing eye pro. Throw your helmet on. Keep whatever hair you guys have. All right. Other than that, this is just my disclaimer that this training is not a all-inclusive training. Get into the torch manual, open it up, read it front to back. All right, it's not that long. It's actually kind of an easy read. It's pretty step by step. Give you a lot of extra information, and I hope that you guys start talking to your shift leads about why we're not doing it this way, why we're not doing it this way. You know, why do we store the torch in this manner instead of this manner? Anything like that. So. Drum up the questions, get out there, cut some steel. If you guys, if we don't have any steel specifically for you to cut, go over to Gary. Make sure you ask Gary and Miles if they have anything they can cut. If they say no, perfect, leave it alone. If they say yes, awesome. But make sure that whatever you cut, that you put back, all right? We don't want create a mess, any more of a mess for them than what we already have. So if you guys got any questions, feel free to reach out to one of your shift leads, reach out to me. Other than that, happy burning, guys.